This is problem 55 on 10.1, and once again, we will not be able to solve it for exact answers. Like, we're not going to get x equals 7, y equals 2. We're going to have like variable answers. So let's go through this here. So first of all, this is a little bit trickier. It is a little bit more of an advanced one, because to get these to cancel out, we're going to need to multiply this entire equation. Remember, we need our x's to be exact opposites of each other. So it looks like I'm going to multiply this one by negative b. So if I distribute through to each piece here, I would have negative abx plus, minus actually, right? Because a positive times a negative is a negative. So then minus b squared y equals negative b. Now if we're going to try to get these to be exact opposites, we're going to need to multiply all of these by a. All right, so then we'd rewrite that equation. We would have positive abx plus a squared y, which equals a. Now when we add straight down, our x's will cancel out because these are exact opposites of each other, which is what we want. So we have a squared y minus b squared y equals a minus b. Now from here, what I'm going to do is factor out the y. So divide by y, because we're trying to solve for x and y, recall. So then left is a squared minus b squared equals a minus b. So then from there, to go ahead and get y alone, we would divide both sides by a squared minus b squared. Divide by a squared minus b squared. So that one is tricky. I'm not going to try to pretend like that wasn't a hard one. It kind of was, just to figure out how to tackle that. But you guys got this. Now, if you'll notice, like, this is why in the problem on the book, they say a squared minus b squared cannot be 0, because it's in the denominator. So that makes sense. All right, so now from there, we'll go and plug that back into one of the original equations and figure out what x is. So let's see. Sorry, I'm trying to do a little makeshift video here. I have to it's a little squishy. So if we plug that in, let's plug that in into the, I don't know, top equation, sure. We would have ax plus b times y, which y is a minus b, over a squared minus b squared. And then that's equal to 1. I decided to plug this into my top equation wherever there's a y. All right, so then really to solve for x, wow, this is not a very pretty answer. I'm not gonna lie to you. So let's see if I can scroll. So what I'm gonna do is recall what we're trying to get alone is x. So actually, let's just go ahead and subtract this whole thing over. So we would have ax equals, we'd subtract that over. So we would have 1 minus b times a minus b over, I'm going to put the b on bottom. Nah, I'll just leave it out in front. And then divided by a squared minus b squared. Now remember, we really technically just multiply straight across. So technically this is b over 1. So I guess I could just put it on top. Now from there, we're going to divide both sides by a, or more cleverly, let's times both sides by 1 over a. So if we times both sides by 1 over a, it's the same thing as dividing by a. So then we've got to times all of this by 1 over a. Now x is by itself. So I'm assuming that the book probably distributes this in. Understand, I would accept many answers here. So then that would become, I'm running out of room. Let's get some more paper going under here. All right, so then this would become x equals, it would be 1 over a minus b over a times a minus b divided by a squared minus b squared. And like I said, I don't know as far as the book goes how simplified they make this, because we could technically get a common denominator, put this together, but to me that's just kind of a lot of work. So I think I'm just going to leave it, and if it doesn't match up with the back of the book, it's going to be an equal answer algebraically. So that one is a little bit hard. I'm going to be honest, I don't think you would see that on an exam for 1050.